So our first speaker is Jessica Cooper, Dr. Jessica Cooper from the Division of Food Contact Notification in the Office of Food Additives Safety at the FDA, in the FDA's Center for Food Safety and Applied Nutrition, or CFSAN. Jessica Cooper is a chemist. She reviews food contact notifications and she assesses food contact substances. And she's also involved with updating FDA's chemistry guidance. She consults on Office of Food Additive Safety research projects. And so she is here by webinar, unfortunately, so you can see her in the upper right-hand corner in tiny version next to her slides. Unfortunately, we can't have her here in person today. Her background is a Bachelor of Science in Chemistry from University of Pittsburgh and a PhD in Chemistry from Carnegie Mellon University. And very happy to hand it over to Jessica Cooper. Thanks.
Good morning, everybody. Can you hear me okay?
Yes.
Okay, thanks. So today I'm going to talk to you about how FDA reviews food contact notifications, and I will focus on the chemistry information needed to support an FDN. In particular, I will talk and discuss migration testing and how FDA evaluates exposure to food contact substances. To begin with, let me start with a brief background of the regulatory background of food contact notifications. The 1958 Food Additives Amendment to the Federal Food, Drug, and Cosmetic Act required food pre-market approval of new uses of food additives, which was defined as any substance, the intended use of which results or may reasonably be expected to result directly or indirectly to becoming a component of the food. This amendment established the standard of safety, the standard of review, and the formal rulemaking procedures for food additives, and this encompasses all the food additives. The standard of safety is the reasonable certainty of no harm, and the formal rulemaking procedures is in relation to petitions and the Code of Federal Regulations, and FDA reviews the data submitted and makes a determination of safety, which results in a regulation in Title 21 of the Code of Federal Regulations. The 1997 FDA Modernization Act is an amendment to the FD&C Act that established the pre-market notification process for food contact substances. And then these food contact substances are defined as any substance intended for use as a component of materials used in manufacturing, packing, packaging, transporting, or holding food if such use is not intended to have a technical effect of food. And this notification process is intended to replace the petition process as the primary means for authorizing the uses of food additives that are food contact substances. And prior to the Modernization Act, these food contact substances were thought of as indirect food additives. The standard of safety and the standard of review are the same for both direct food additives and food contact substances. The features of a food contact notification that differs from a food additive petition is that it has a 120-day review period after the receipt of a complete submission, and then it is exclusive for the manufacturer or supplier. Once a food contact notification becomes effective, it is listed in our inventory of effective notifications on our website. So what is a food contact notification? It's basically a data package that demonstrates the human safety, and it has the following parts. It has the identity of the substance, the intended use, exposure information, safety narrative, and an environmental assessment or claim of categorical exclusion. Now, all this information is needed for a food contact notification to be considered complete. I will be focusing on the chemistry information, but as you know and be aware of, that there is a toxicology component and an environmental component along with the chemistry information. The chemistry information is reviewed to establish the identity of a food contact substance and for assessing the potential consumer exposure to the substance. And all of the chemistry information must be supported with supporting analytical data. Now, we have guidance documents on our website for the chemistry information. We also have guidance documents for the toxicology and environmental components, as well as administrative and regulatory background. So for the chemistry information, we have a long list of the types of information that's needed. First, we have the identity. This is the chemical name of the food contact substance. This must be specific to the food contact substance, and any other information that uniquely identifies it. That includes the physical chemical specifications and the manufacturing information. Also, we have to have a list of the impurities. When we talk about a food contact substance, and throughout the talk, I'll probably just be talking about food contact substance or the FCS, but when we think about migration, we don't think of just the food contact substance itself, but also its impurities, and that can include anything from starting materials to residual catalysts or processing aids, or even any breakdown components or byproducts. So when I'm talking about migration, I'm talking about all of those constituents as well. The next set of information is the condition of use. How is the FCS going to be used? This details the types of food it's going to be coming in contact with, whether it's aqueous, acidic, alcoholic, or fatty types of foods. The use level, how much of the food contact substance is going to be used in the food contact article, and the time and temperature of use, whether it's going to be used in a can coating, so that would be used for a high temperature retort versus, say, just for frozen foods. Next, we have technical effect. What is the technical effect of the food contact substance, not on the food, but in the food contact article? And the type of information we're looking for here is what is the minimum, is the use the minimum amount to achieve the technical effect. Also, stability must be addressed. How is the food contact substance going to remain stable throughout manufacture and use? And if the food contact substance is going to break down in either the use or the manufacture, and if it does, what are the breakdown products? Then the migration levels of food, what's the concentration of the FCS and its constituents in the food, and then exposure estimates. So when we look at all of these types of information, what we're really looking for is asking a couple questions, and that is, what is the FCS and what has the potential to migrate? And this question of what has the potential to migrate addresses components that come along with the FCS, which is the impurities or breakdown products. Then how much of it is migrating? What's the concentration of the food? And then of that, how much are we then consuming? The migration data is used to assess the potential consumer exposure, and migration in food can be estimated in two ways. We have migration testing and calculation. For the migration testing, we have a lot of information in our guidance, so if anybody wants more information on that, I really suggest going to our guidance. It gives a lot of the time and temperature conditions that we recommend for migration testing for each of the different conditions of use and for the different food types. The migration testing is consistent with the intended conditions. That includes the use levels, the food types, and temperature. For instance, if a food contact substance is only going to be used at a level of 5% in a food contact article, then it should be tested at that use level and with the specific food types and temperatures. We also have recommended food simulants. Migration testing can be done on real food, but due to difficulties in analytical testing, oftentimes it's easier to do food simulants, so we have a list of recommended food simulants in our guidance as well. So once the migration levels are determined, we have exposure assessment, and this estimates the probable consumer exposure in terms of the concentration of the food contact substance in the daily diet or the estimated daily intake. And the way that the exposure assessment is calculated is a combination of the migration levels determined from the migration study with packaging information. So let me talk a little bit about the packaging factors that are used. So we have two different types of packaging factors. We have the food type distribution factor, which is the distribution of the packaging among food types. So this is taking into account the fraction of the different foods for each food type. So for instance, if we're looking at polymer-coated metal, what is the fraction of polymer-coated metal that is in contact with each of the different food types? So in this case, the food type distribution for aqueous foods is 0.16, and in other words, that's saying 16% of polymer-coated metal is in contact with aqueous foods, and 35% is in contact with acidic foods, and so on. Now, the second packaging factor is consumption factor, and that's taking into account the different types of packaging that we have. So if you think about things that you eat throughout the day, each of the foods might come in contact with different types of packaging. So consumption factor is the fraction of the daily diet expected to contact specific packaging materials. And we have, for instance, the consumption factor for polymer-coated metal is 0.17. So of all of the different food packages we have, 17% is come in contact with polymer-coated metal. So how does all of this work together? For the concentration of the SDS in the daily diet is calculated by first you do the total migration. That's taking into account the different types of food. So the total migration is taking into account, for instance, we have the migration experiment, and if the food contact substance is to come in contact with each of these different food types, then the migration experiment must be conducted with each of these food types. So the total migration is taking the food type distribution, multiplying it by the migration in that food type. Once the total migration is determined, the dietary concentration is then calculated by taking into account the consumer, the consumption factor. So the dietary concentration is then the amount of migrant in the amount of food in the daily diet. To calculate the estimated daily intake, we're assuming that one person consumes 3,000 grams of food per day, and then the estimated daily intake is calculated by multiplying the 3,000 grams by the dietary concentration. So to try to make this all fit, all that information kind of fit into a picture, I wanted to give you an example. So we have, for example, if a food contact substance is a copolymer intended for use as a component in can linings, the food types, the notifier has to give all this information. The notifier gives us the information that it is intended to come in contact with aqueous, acidic, and fatty foods, and it's intended for condition of use A, which is high heat, sterilize, and retort, and the maximum temperature would be 121 degrees C. Then with all the chemistry information, again, they would have to give the identity, the manufacturing information, and impurities. And with the impurities, they're listing the possible migrants, which would be, in this case, oligomers, monomer A, monomer B, and an impurity C. And a lot of times we'll see a larger list, but this is just to give you an example of the different migrants we will be looking at. So for the migration testing, we would recommend the test sample to be the coating that contained the SDS at the use level that is supposed to be used, and then in contact with the food simulant. So we have the SDS was supposed to be used in contact with aqueous and acidic foods. We recommend 10% ethanol for both of those. And then if it's in contact with fatty foods, we recommend migliol. For test conditions, for the retorts, we recommend test samples are heated at 121 degrees C, held for 2 hours, and then 40 degrees C for 238 hours for a total of 10 days. Samples must be taken at 2, 24, 96, and 240 hours and done in triplicate. Now, we have, again, all of this information is in our guidance, and depending on the conditions of use. So if it's going to be used at different temperatures, we have different testing conditions. And then the test samples should be analyzed for all of the possible migrants, not just the FCS. So what we would get is something like this. If we look on the left, we have a table of the migration results. So for instance, we look at the migrant, we have food contact substance oligomers, and then we have migration levels for each of the different food types. So we have for ethanol, and we have for migliol, and usually this should be reported in units of micrograms per gram. So then we have migration values for each of the migrants, and then also there are times if it's not detected and it's below the limited detection, we would require analytical data to support all of these levels, including the limited detection. So if we look at, so this is an example, and if we go over to the exposure calculation, for the FCS oligomer, as an example, we would take the total migration and we take the food type distribution, multiply it by its migration in each of the food types, and then we get the total migration. Dietary concentration is you multiply the total migration by the consumption factor, and then you get the estimated daily intake. So then in the end, you would get migration, you would get exposure estimates for each of the different migrants as well. So we have estimated daily intake for each of these. Now, once the exposure estimates is calculated for all of the migrants, then that would be all the chemistry information that would be needed, and then the toxicology information in the food contact notification must be submitted to support the exposures of all of those migrants as well. So that is all that I have to talk about the migration and exposure calculations.
Great. Thank you so much, Dr. Cooper. And since we won't be able to have Dr. Cooper with us for the panel discussion, she's said that she's willing to take some questions now from the audience. So if anyone has any questions, please feel free to offer them up. I see that Marty has a question in the back, so let's start with Marty.
Hello, thank you for that. I'm curious, how were the ethanol and miglol migration tests validated and developed, since they're serving as a proxy for the contact to those types of foods? I'm sorry, I heard the first part.
Oh.
How were they developed?
How
and I didn't hear the second part.
Developed and validated. So what's the thinking behind those as proxies for contact with those types of food, and how was that validated?
I'm sorry.
Maybe I'd better repeat.
Dr. Solomon, would you be willing to repeat the question?
Sure thing. So the question is, with the food contact migration testing, how are those tests validated? And I think that relates also to one of my questions, which is, the duration, for example, is 10 days. We just heard from Dr. Lakine's talk that the shelf test for functional characteristics typically is done for a full 2 years to be sure to capture functional issues during that time. But the migration testing is 10 days. Has that been validated to be sure that that would capture migration over the full lifespan of a can?
Oh, yes. So the studies, there were studies done in the 80s, and the testing, if you see, it's done at an accelerated temperature and time. So the accelerated temperature was shown to be able to accurately approximate the migration throughout the long-term storage.
So what I'm hearing from your answer is that the testing for 10 days at 40 degrees centigrade was validated back in the 1980s against
yeah, it was,
testing.
So the short period, the high temperature of the short period, and then the 10 days is the elevated temperature that compared to. Hold on one second. I don't know what that says. What are you saying?
Yeah, the original AD Little compared the polymers with foods. That was years ago, and now even in the EU they have the MicroSure project, which was the foods with them.
I'm sorry. So we have, so the accelerated time and temperatures that was able to show that there was testing done for the long term, and then the values were compared to the elevated, the accelerated time and temperature ones. So they are comparable.
Okay. So one more question or maybe a comment on this point, and then Janet, I can go to you to save you from writing if you want. So. No. Well.
If I can just make a comment from the EU side. Emma Bradley from FERA, I'll be talking next. But basically, we participated in a European Framework 7 funded project relatively recently, where we tried to consolidate a lot of the data that was the validation data from the 80s. I know when I started working in the area, I was like, so why did you choose that? Why did you choose that? Why did you choose that? And there wasn't necessarily the data that we would accept today as validation. But this project, which was called Food MicroSure, we did a lot of measurements comparing migration into simulants, comparing migration into foods, and demonstrating that they were valid.
Great.
And all of that is public.
And we
all
can
of that's
talk
public,
more about that in the
funded.
panel discussion too. Sorry, I thought it was. Let's pass it to a question for Dr. Cooper.
Hi, thanks so much for your presentation. My name's Janet Noodleman. I'm with the Breast Cancer Fund. And a lot of today is about how information does or doesn't flow along the supply chain. And as a consumer and an advocate, we tend to occupy the lowest rung of that supply chain ladder, if you will. So my question is, of the information that you gather from manufacturers as a part of the food contact notification process, how much of that information is readily available to the public?
So, I'm sorry. Did you hear the question? The question is about
how much of the information that we get from manufacturers, how much of it is what?
Is available to the
I didn't
public.
hear that part.
The question was how much of that information that the FDA gathers is available to the public?
Oh, okay. Well, anybody can ask FDA for information through the FOIA requests.
So not so readily.
I'm gathering that there's some skepticism in the room
like
about the FOIA process.
Well, a lot of information, if we have a lot of information, the information that we gather is used to help us with our regulatory science, and for the most part, when we do gather that information, we'll put that into guidance documents. So we may not name the sources, but all that information is used to do the guidance documents. Now, some of the information, unfortunately, is going to be confidential because these are things like manufacturing information. But if we use a large amount of data to figure out like maybe consumption factors and that sort of thing, that type of information goes into our guidance.
So is the information, how much is put on the FDA website of the information that you have described to us? In other words, are the migration tests available, or the calculations on?
Yes. All the migration testing is in our guidance document, and you can look through the guidance, and the chemistry one in particular, and you can go through that if you have, depending on the conditions of use, and the food types. All that information is on our guidance, and that's readily available. And all the other information that's needed, as far as like the toxicology and the environmental, that's on our website as well.
Okay. Another.
Are you talking about the results of the migration? Or?
Yeah. Not the methodologies, but actually the results for individual linings. Is that possible to review or available?
No, you would have to do that through FOIA. On the website, we have the name of the food contact substances, the use and the use levels, and that's what's published on our website.
Okay. And there's one quick additional question, and then we have to move on. So I'll take the question from the gentleman in the audience who has the microphone. Or no?
We have a question.
Oh, there are two questions. Okay. We're out of time for this, but go ahead.
Okay. My question in terms of like doing the calculations, you mentioned that it's required to list information even if it's non-detect, but I know that a number of us from the advocacy community
I can't hear at all.
I'll repeat the question.
Are deeply concerned about endocrine disruptors, which are at extremely low levels. And so I'm just wondering, in terms of the chemicals that are found or the impurities, are those all required to be tested at levels that are actually detectable?
I think this question might be better asked of the toxicity panel, because you're asking about the limit of detection in the test. Okay, sorry, this is a chemistry question. So the question is about whether the limit of detection in the tests is where those are set, and how sensitive the test methods are to pick up even fairly low quantities of migration.
So the limit of detection would be established by the analytical method that is used by the notifier, and with the limit of detection, as I said, all the analytical data would need to be supported. So therefore, they would have to give that information. As you may expect, with all the different types of food contact substances out there and the different types of chemicals that we're looking at, you're going to have a wide range of analytical techniques. So they all are going to range in the different limits of detection. So when we look at them, we're going to look at them in a case-by-case basis, and they would have to establish the limit of detection of that analytical procedure at the time of giving the information. So oftentimes, if we have a limited detection, they would have to show, how they got that, the signal to noise ratio and all that. So, and often it's in the notifier's best interest to make sure that the analytical technique that they pick is going to be sensitive enough to have a low limited detection, or else in their exposure estimates may be higher than it actually is.
Okay. Thank you, and thank you again, Dr. Cooper. I'm sorry we have to move on. So thanks.
Thank you.